Hello everyone. In this video, we will be solving the problem valid Sudoku. The number of the problem is 36 on LeetCode. If you have played Sudoku before, then the rules must be pretty familiar to you. But for everyone else who haven't played Sudoku, I'll just go through the rules. We have to determine if the 9 by 9 Sudoku board is valid or not. Only the filled cells needs to be validated according to the rules. So we do not have to fill out the remaining cells to see if the Sudoku board is valid or not. Just look for the values that are already provided. The first rule is each row must contain the digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. Each of the 9 3 by 3 sub boxes in the grid must contain the digits 1 to 9 without repetition. A couple of notes that the problem statement has is a Sudoku board, if partially filled, could be valid, but it is not necessarily solvable. Only the filled cells needs to be validated according to the mentioned rules. So again, we do not have to work on all the blanks in this Sudoku board. We only have to look at the values that are already provided. So if you look at the example number 1, it would take some time to go through all the cells and validate it, but the gist of it is this board is valid because it has all the right numbers in the right spots. But if you look at the board number 2, this is invalid because this number 8 is repeated twice in column number 1. So this board becomes invalid. Let's go to the whiteboard and see how it can be implemented. I will be using the example number 1 from the problem statement to understand how it can be solved. I believe this problem doesn't need any kind of an algorithm as such. It is more dependent on our problem solving skills. As the problem is asking us to look at the rows, columns, and the boxes, we will be defining a dictionary or some sort of a variable which will hold all the values that are provided in the input. I will create 3 variables here, and these 3 variables probably need to be a 2D, 2-dimensional or something which has a key and a value. The key will be the identifier, like for row, the key will be the row number, column will be the column number, and box, we can say it's a box number. The first 9 boxes, 3 by 3, will be box number 1, then the number 2, number 3, and etc. We can define that rule ourselves. Row and column is pretty straightforward. So let's say we create a dictionary or a 2-dimensional array. For simplicity, I'll do a 2-dimensional array, but in each entry, we will not be saving only one value, but we will be saving a collection of values. In all of the 3 variables, the first entry would be the row number, index number, or box number, and the second would be all the numbers that are present in that row or in that column or in the on the box. All the numbers are going to be present in all the 3 variables. So for this phi, if I were to enter it in these variables, its index would be, so for row, it will become r will be, so my index is going to be 0, and here I will add the number. So on row number 0, let's say I'm creating a new list here, so I will add 5 and then wait for the remaining characters whenever I'm scrolling through. So basically, when I'm iterating through all the numbers in the given board, I will keep on adding it to these boxes or to these variables and make sure that those numbers are unique. I should not be getting the same value again. If I get it, I should throw an error saying that it's an invalid Sudoku board. So I start with 5. So after adding it for row, let's add it for column as well. So for column, the column number is 0 and I add 5. And for box, my box is 0 again, and I'm adding 5. Okay, I'll keep the brackets bigger so I can add more numbers to it. So I will continue looping through all the numbers in the board. After doing it for 5, I am on this empty. So if it is empty or dot in the input, we have to ignore it. Ignore. Now I am on 7. Okay. So for 7, if I'm adding it to the row variable, the index is going to be 0. So I will add it the same variable, and then here I'm adding 7. I made sure that 7 is unique in this so far, which is true, so I can add it without any errors. After adding it to the row variable, we need to add it to the column and boxes as well. I'll continue looping through further. Empty, empty, empty. Now I am on 6. Now for 6, my row was incremented by 1. So I need to use another row with index 1 instead of using the previous one with index 0. R of 1 and then add 6. Also, I need to add it to the row column variable. So column is still 0. So I can add it to this column variable that's already created. It is unique, so I can add it without any error. So adding 6, and this is still the first box. So I can add it to my box variable, the one that I've already created. So 5, 6. Similarly, you can keep on incrementing through all the numbers in the Sudoku board and make sure that you are adding it and the right index. And if at any given point of time you find a number being repeated in that index, in that variable for that given index through an error, for example, let me put a random variable here which will make the board invalid. So I'm putting a 6 just next to the number that we just covered, and this is repeated in the box. So after going through this variable, if I increment my counter, so I'm now pointing at this 6, which is in box number 1. So it should be added in this box. If I were to add it, first I need to validate if the 6 is unique or not, which is not unique. So I will not be able to add it, and I can say that this board is invalid and I can abandon the whole process. I hope you were able to understand the approach. It is simple. It doesn't seem to me that it's a medium level problem when you understand the concept. The time complexity for this solution is O of m into n, where m is the number of rows and the n is number of columns. So in this case, if it is 9 by 9, so it's O of 81, because we are iterating through each and every number only once. Our space complexity is 3 into m into n, because we are creating 3 different variables and each variable is going to hold the value. So it's like we are saving the value thrice in 3 different variables. 3 is sort of negligible, so it's the space complexity is O of m into n. So for this the approach that we just discussed, let's look at the C# implementation. Like we discussed in our whiteboard session, I have created 3 variables for rows, columns, and boxes. It's a dictionary of integer and hash set. Integer means it will be holding the values of the index, like the row number, column number, or the box number. And the hash set of character, it will hold the values that are available in that corresponding row, column, or box. The property of hash set is to have all the values unique. So if I'm trying to add a duplicate value, it will return me false, and I can directly throw an error based on that. The flow starts with iterating through all the rows. I get the row and then start with the column. So I'm getting the value in this field variable and then verifying if the field value is not equals to a dot, which means empty. So at each layer, I'm checking if the row was already being iterated. If it was iterated, then I will find this contains key will return true. I try to add that field to the row. Is it throwing an error or not? Because it's an hash set, if my addition is successful, it will return me true, or else it will return me false. So in case if it is returning me false, I'm setting my result variable as false and I'm breaking the loop. If I haven't iterated through that row before, I'm creating or adding a new entry to the rows dictionary with I as my index or key and creating a new hash set, adding field to it. Just like the rows, I have the same logic for the columns as well. to get the box number is slightly different because the box numbers are determined by I and j together. So I have built a helper method that returns me the box number depending on I and j. For example, if my I is less than 3 and j is less than 3, it means I am looking at box number 1. If my I is less than 3 but j is greater than 2 and less than 6, it means it is box number 2, and so on and so forth. So using this helper method, I am calculating the box number, and then using that same logic that we discussed earlier for rows and columns, I am calculating if the variable is already added to the box or not. If it is added, throw an error. If not, then add it to the list. And at the end, after the whole flow completes, I am checking if my result is true or not. If the result is true, I return true, else I return false. I hope you were able to understand this solution and the whiteboard session that we had. If you have any questions or concerns, please feel free to reach out to me. I will be adding the link to this solution in the description below, and I will see you in the next one. Thank you.